So this is another question number 157 from NEET 2018 examination, and it is again a very simple question. What is asked in the question is carboxylic acids have generally higher boiling points than other compounds like aldehydes, ketones or alcohols which have comparable molecular masses. We know that if molecular mass increases, normally boiling point increases, but when they have comparable molecular masses, that means almost similar molecular masses of all these compounds, whether it is aldehyde, ketone, alcohol or carboxylic acid, if we compare them, carboxylic acids have higher boiling points. So what is the reason for that? That has been asked in the question. Okay, so the first says that van der Waals forces. Okay, so van der Waals forces is something that is dependent on many other factors. Okay, and if your molecular mass is higher, okay, the boiling point increases, but because it has been said that for comparable molecular masses, so this option rules out. Okay, because when comparable molecular masses are there, so comparable van der Waals forces will also apply there. Okay, now the second thing is intramolecular hydrogen bonding. Okay, so we know that carboxylic acid is capable of intramolecular hydrogen bonding, provided it has such a structure. Okay, but normal, if you look for the normal carboxylic acid, it is not capable of doing intramolecular hydrogen bonding, and more or less intramolecular hydrogen bonding does not affect the boiling point. Okay, because the hydrogen bond is happening inside the molecule itself. So molecule is in solution or it is in gas phase, it does not matter. Intramolecular hydrogen bonding will always work and it is not going to affect boiling point. Okay, so this option is also incorrect. Intermolecular hydrogen bonding is one reason which increases the boiling point, because intermolecular means the hydrogen bonding between two different molecules. Okay, so now if two molecules are say attached together with the help of hydrogen bonding, so that means it will, so one molecule in the solution phase will try to attract the other molecule, and the boiling point will simply increase. That means sending one molecule to the gas phase, which will have to overcome the force of attraction or the force of this hydrogen bonding that the other molecule is exerting on it. Okay, so that means intermolecular hydrogen bonding may be one of the reason. Okay, and formation of carboxylate ions is not, it cannot be a reason, because it is an ion, but it cannot be a reason because there is nothing to hold our ion back in the solution. Okay, intermolecular hydrogen bonding can be a reason, and we know that carboxylic acid, so let's say you have a R group and then you have this and then you have some carboxylic acid, and we know that most of the carboxylic acid exists as dimers. The simple reason is intermolecular hydrogen bonding. So this option is the correct option. Okay, look here. Okay, so there is this hydrogen bond and this hydrogen bond. Okay, so carboxylic acid exists as a dimer and intermolecular hydrogen bonding is operating between them, and at any place when intermolecular hydrogen bonding is there, boiling point will always increase. So option number 3 is the correct option for this question. Okay.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.